Hello and welcome to your video to explain to you how you are going to do Lab 3 graphing. So put your name up here and you will either take pictures of this lab and submit it on the assignment on Google Classroom, or you can hand it in my mailbox in the main office. You can ask someone in the main office how to do that if you need help. So to introduce, scientists study the ways in which different objects and phenomena in the universe are related to one another. They frequently plot graphs with the information they collect in order to understand it better. The characteristics of the graph usually reveal much about the relationships. So graphing helps you understand relationships. Not like who you're dating, but how variables relate to each other. So you're going to create graphs, you're going to construct proper graphs, and determine relationships. Graphs indicate whether the relationships are direct, indirect, static, and cyclic. If you're not sure what those are, check out the notes section for the CASEL learning assignment. In general, direct means that as x goes up, y goes up, and it looks like this. Direct. Indirect is going to be the opposite of that, with x and y. As x goes up, y goes down. So this would be like you spend more time at a store, you're going to spend more money. This would be like you spend more time at school, you get less happy. Static means not moving or not changing. So it means the relationship between x and y doesn't change. The more time you spend at school, you're still the same height. You haven't grown. And cyclic. Cyclic sounds like cycle, like bicycle. And it's for things that change but repeat how they change. So things that go up and down like this. So how much sunlight we're getting. We get more sunlight during the summer, less in the winter. More sun in the summer, less in the winter. Or tides. Tides go up, tides go down. Tides go up, tides go down. Or the moon phases. Full moon into new moon, into full moon, into new moon. Some important things that you need to know are that we have dependent and independent variables. Sorry for crossing those out. I'll grab a highlighter. Dependent and independent variables. The dependent variable is what's being measured in the experiment. It's what depends on your experiment, and that goes on the y-axis. The independent variable is the one you know in advance and control, and that goes on the x-axis. So x, independent, y, dependent. So if we take the temperature reading of a lake every 5 minutes, temperature depends on what time we take it. So temperature is the dependent variable and time is the independent variable. Time would happen even if we didn't take our experiment, but we only know the temperature because we're doing the experiment. For this lab, you're going to need a calculator. You can just use a phone calculator, that's fine, or the one built in on your Chromebook, and a pencil to graph with. And you're going to answer questions on the next few pages and label your answers when appropriate with things like units. Alright, that's the introduction, and I will show you how to do part A in just a minute. Awesome, here's part A. So we're going to base our answers on the graph, which has the flight. Is the flight of 2 weather balloons that were released from different locations, and we have the height of those weather balloons after different amounts of time. So was the altitude of the balloons increasing or decreasing, shown by lines A and B? A is going to be the blue one, and B is the green one. Triangles and squares if you are color challenged. Okay, so was it increasing or decreasing? Well, over time, the height went up. That's going to be increasing. During the first 4 minutes, how many meters did balloon A rise? So at 0, it was at 400, and at 4, it was at 800. So how many meters did it rise? 400, and we take that away from 800. 400 subtracted from 800 is 400, just like 8 minus 4 is 4. So 400, and what unit do I put? meters, which I can abbreviate with an M, or you can write the full word out. How about for balloon B? I'm going to grab a different color for this one. Balloon B started at 0 time, and at 4 minutes is at 400. So 400 minus 0, that's going to be 400 meters. Awesome. We can go over here for question 4. That's going to be on your next page. During the first 4 minutes, what was the rate of increase for balloon A? So it says to look at page 1 of your reference table. You pick that up with your materials. That says that rate of change equals the change in value divided by time. Awesome. So what was our change in value for the first 4 minutes? Well, we saw that it changed by 400. We got the answer for that one in 2. And how long is 4 minutes? Well, it's 4 minutes long. So what's 400 meters divided by 4 minutes? It's 100 meters per minute. Delightful. Now how about for B? We use the same equation. The change we have right here, and the time is still 4 minutes. I think you can do this one on your own. All right, now for part number 6, you're going to have to do those steps all together. So we're still using the same rate of change equation. How much did it change by from 4 minutes to 8 minutes? Well, at 4 minutes it was at 800 for A, and at 8 minutes it was at 1,200. So you're going to have to do 1,200 minus 800. And how many minutes is that from 4 to 8? That's going to be 4 minutes. I think you can solve this one on your own too. All right, 7. Again, same equation. Let's see. I'm going to erase some of these things, my lines on here, because they're getting a little messy. So now I want the rate of change along line B, the green triangle one, from 4 to 8 minutes. 4 to 8 minutes, still 4 minutes of time, but let's see what the change in value is. 4 minutes is here at 400, and 8 minutes is here at 600. So you'll have to do 600 minus 400 meters. And then do your division, divide by time, and solve for it. And I think you can do that too. And do these show direct or indirect? Remember, direct looks like this. Indirect looks like this. Which one do they look like? You can choose. All right, I think you guys have got that. I'm going to go and show you how to do part B. All right, welcome to part B. This one you're going to actually do some graphing. So a cup of hot water was left standing on a lab table. The temperature was measured and recorded at 1 minute intervals, which we see here in time. And we're going to plot the data given on graph B. And we need to label our axes. So this one, first we're going to start with labeling our axes. We need to decide what's going to be the independent variable, what happens without our experiment. Well, even if there was no cup of water on the table, we would still have time passing. And it makes sense for time to be here because it's the one that goes from 0 to 15. We can't actually plot time over here. The numbers don't match. So time in minutes, which leaves this one to be, I'm going to write it this way, temp in degrees Celsius. All right, great. Now we're going to plot. So we have at 0, it's at 36. I'm going to put an X so it's easy for me to see. At time 1, it's 32.5. Right here, halfway in between 32 and 33. At 2, it's 30.5. I'm going to pause this video and plot the rest of them real quick. Alright, I've plotted all my points and I connected them with a line, so now we can work on some questions. Did the temperature increase or decrease? Well, as time went on, the temperature went from 36 to 23, so it decreased, it got smaller. and rate of change from time 0 to time 4. I can look right at the data table for this, which is nice. The numbers are exact from the data table. So remember, rate of change equals the change in value divided by time. So my value went from 36 to 28. So 28 degrees minus 36 degrees. Because it went down, I'm expecting that number to be negative. That's why my bigger number is the second one and my smaller number is the first one. And my time was 4 minutes, 0 to 4. That's degrees Celsius. So 28 minus 36 is going to give me negative 8 degrees Celsius in 4 minutes. So how many degrees per minute? Fill that in there once you've done your division. Remember, it should be negative. Now how about from 4 to 8 minutes? That's going to be 4 minutes of change. We're going from 28 to 24.5. So we use our same equation. We have 24.5 degrees Celsius minus 28 degrees Celsius. Figure out what that number equals and divide by your 4 minutes. Make sure you do the subtraction first and then divide. Do it in 2 steps. And again, you're going to get your answer in degrees Celsius per minute. I have something blocking that on my screen, so I can't. Right up there. Does the graph show direct or indirect inverse relationship? Well, remember, direct looks like that, going up and up, and indirect looks like this, or sometimes it's curved. So that one's going to be indirect. And is temperature or time or temperature, the independent variable? Independent is the one that's down here on the x-axis. So fill it in. You know what it is. Awesome. Part C, our last part. So this one's cool. It's about density. So we've got a density graph with mass and volume. And I want to find the density of pyrite. So remember, density equals mass divided by volume. So we could pick, I could pick any point on the line, and I'm going to pick this one. This one looks like a nice point. So the mass at that point is 100, and the volume is 20. 100 grams and 20 centimeters cubed. So 100 grams divided by 20 centimeters cubed. And you might say, Ms. Halleck, what if I picked this point over here? Well, that's 175 grams divided by 35 centimeters cubed. That's going to give you the same number. So with this one, 25 grams divided by 5 centimeters cubed. All of them will give you the same number. If you don't believe me, try it. All right, now what if it was 50 centimeters of a volume? For that one, what you're going to want to do is continue this line. Let me see how straight of a line I can draw. So you can use a ruler, a straight edge, anything like that. Look at the chart for 50 centimeters cubed. Go up and see what the mass is going to be. Hopefully you got that. Make sure you put your answer for this one in grams and your answer for this one in grams per centimeter cubed. All right, discussion questions. What happened to the rate of increase? Let's go up and look at that. So the rate of increase, you've got it at 100 meters per minute here, and what do you have it? And probably the same for B. But it's a different number for number 7. So what happened to the rate of increase for A and B? A has the same slope the whole time, but B's slope goes from being steep, big slope, to less steep, a smaller slope. So for A, the rate of increase is the same the whole time, but for B, it's not. Make sure you explain to me how it's not. Did it get bigger or smaller? For temperature and time in part B, what happens from 12 to 15 minutes? Well, 12 to 15 minutes, is the temperature changing or is it staying the same right here? A dependent variable that's not changing with time. This one is going to be static. So go back to the beginning of the video if you're not sure what a static relationship looks like, and show me a static relationship. You can just put x and y and then draw me a line. It's either going to be like this, like this, like this, or like this. Pick which one matches static. And describe the advantages of plotting data rather than reading the same data. So if we look at part B, why is it better? Like, why does it make more sense to look at the graph than to look at the data table? How does the graph make it easier? I would talk about maybe like how easy it is to see that it was fast at the beginning and slow at the end. Maybe to see how big the change is. Lots of different explanations for that. All right, you guys have got this. You're doing great. You're awesome. If you need any help with this, if this video was confusing or you want some more specific advice what to do, feel free to reach out to me.